Okay, we are now in section 3.7 and it's called Implicit Differentiation. And I'll tell you why that's what it's called and you'll figure it out eventually. Okay, look at all these following functions. Suppose we are asked to find the derivative dy by dx, or sometimes we want to refer to it as y prime of, say, y is equal to x squared, and we say that what? Y prime is equal to x squared, 2x, right? Okay, what about this? Okay, y prime is what? 2x plus the cosine of this argument, 2x minus 3. And then we don't stop there. We multiply by the derivative of the inside, which is times 2. So sure enough, we can get the derivative of all these. What about this? Oh, you should be experts now. You know how to take the derivative of a polynomial using the power rule and the sum rule and all that. So y prime here would be what? 3x squared plus 8x minus 0. Okay, because the derivative of constant is 0. Now let's look at this other side, and we will still ask to find the derivative of the following. But look how these equations look like. You have y squared is equal to x. We don't know quite yet how to take the derivative of y squared equal to x, so we might have to solve for y first in terms of x. Maybe that's another way of looking at it. Here you've got an equation of a circle. See, that's x squared plus y squared minus 25. Remember, that's r squared. So again, we might have to solve for y in terms of x again. This we can still handle, this we could, but what about this next problem? Look what we've got. We've got the cube of y, the square of y, and then x is multiplied to y. All of these are what we call implicit functions, where y is implicitly defined. That means it's embedded in the equation, and so we don't know quite yet how to take its derivative. Right, so suppose we didn't know yet. Well, right now we don't know how to use implicit differentiation because I haven't told you yet. So suppose we don't know how to, the only thing we know is just to find dy by dx, where y is explicitly defined in terms of x. So what we're going to do is we need to solve for y in terms of x. Okay, so we've got y squared equal to x. Take the square root of both sides, we're going to get y is, right, you do that. And of course, when you do the right-hand side, we got to do plus or minus the square root. So it's going to be y is equal to plus or minus the square root of x. So what we have are two functions. Let's call it y1, which is the square root of x. So it is represented by the square root function that's above the x-axis. Okay, when we have the positive square root. And then another one would be y1, or rather y2, is equal to the negative of the square root of x. So we split this relation into 2, that way we'll have two functions in terms where y is solved explicitly now in terms of the x. And we know this by power rule that y1 prime would be 1/2 x to the negative 1/2, or that's 1/2 square root of x. Similarly, here y sub 2 prime would be, it's negative 1/2 square root of x. So we still can do it, but I think we worked harder because first we had to solve for y in terms of x. What if we don't need to do that? Then life would be easier. Let's say we now are going to use implicit differentiation to find dy by dx, or y prime, just because it's easier to write y prime. And in order to do that, what we're going to do is simply imagine that y is a function of x, so we just apply the differentiation rule of power rule on y squared right here. But we don't stop there because y is a function of x, so we multiply by chain rule dy by dx whenever we take the derivative of a y expression. So let's do that. Alright, so now let's see, what did I say? We differentiate both sides and term by term. But here we just have a single term, but in general we do term by term. This is the most important thing. We have to differentiate with respect to x. So what do I do now? What is the derivative of y squared? The derivative of y squared with respect to y is simply 2y. But we are interested in y dy by dx, so we multiply by y prime. And then on the right side, it's just, what's the derivative of x with respect to x? It's 1. So y prime is just divide both sides by 2y. We get 1 over 2y. And that is exactly what we got from the previous slide. You see, this is your y. Y is the square root of x, or the negative square root of x, depending on which function you're looking at, whether this one or its negative counterpart. Look at this. See, there's your square root of x right there. So we did it in just what, 2 steps? So here's where it's convenient to use implicit differentiation whenever we're looking at a function of y implicitly defined in an equation. Okay, here we've got an equation of a circle. So our problem is to find the slope of the line tangent to the circle x squared plus y squared equals 25 at the point 3, negative 4. Now where's 3, negative 4? 3, negative 4 is in which quadrant? It's in the 4th quadrant, right here. If we had to solve y in terms of x, right there, then we'll get 2 equations again. This upper semicircle and the lower semicircle. And see how you have y sub 1 is the square root of 25 minus x squared, and then the other one is the negative square root of 25 minus x squared. And then when we take y prime, that we're going to have to use chain rule and so on and so forth. But look at this. Suppose we use implicit differentiation, then it would be easier. So what is it? How do we do implicit differentiation? First, we differentiate both sides, term by term with respect to x. And every time you encounter a y, you multiply by y prime. Okay, so what is the derivative of x squared? 2x. What's the derivative of y squared? 2y times y prime, because we use chain rule. And then it's equal to the derivative of a constant is 0. Okay, so there you go. You have 2x times 2y prime equal to 0. And then the rest is just solving for y prime. Okay, so we put 2x to the other side and we divided both sides by 2, and that's how we got this term. And then we divide this by y, and that's how we get y prime. So y prime is equal to minus x over y. And all we do now is just substitute the x and y coordinate at this particular point. And that's how we got 3 over negative 4. So the negative of a negative is 3/4, which means the slope of the line tangent to the curve is 3/4, which makes sense because look, you have a line that is sloping upward. So you should have you expect to have a positive slope. Okay, we're not done yet. So far, what did we do? We found the equation of the line tangent to the curve. We haven't gotten that yet. All we found is the slope. And then what's the next thing? We have to use the slope point form on this point, and using that slope that we got in the previous slide. So what is the slope point form? It's y minus y1 is equal to m times x minus x sub 1. So what is our y coordinate right there? So substitute it right here, equal to the slope that we got, and then x minus x sub 1, which is 3. And then when you combine all the like terms, first you distribute that here, and then put 4 on the other side, you know, this becomes y plus 4, and when you put it on the other side, this is the equation of the line that you're going to get. In other words, what is the equation of this line? It's y is equal to 3/4 x minus 25 over 4. Alright, so how do we do implicit differentiation from the 2 examples? Okay, first step, differentiate both sides of the equation with respect to x, treating y as a differentiable function of x. That's why every time we encounter y, after we differentiate y, we always multiply by y prime because it's a function of x. We apply chain rule. And then we collect all the terms that has y prime or dy by dx on one side of the equation, and then solve for dy by dx. Let's look at this problem. You have y squared is equal to x squared plus sine of xy. So again, we cannot solve for y explicitly here, so that's why we use implicit differentiation. So what's the first step? It says here, differentiate both sides. With respect to what? With respect to x. So every time you have a y expression, you have to multiply by y prime after you've differentiated that y expression with respect to y times y prime, because remember, we're looking for dy by dx. So let's see. What is the derivative of y squared? 2y times y prime, chain rule, is equal to, what's the derivative of x squared with respect to x? 2x. Plus, now what do we employ here? Chain rule, because what's the derivative? What's the big picture? What's the outside function? It's sine. So what's the derivative sine? Cosine of xy. Multiplied by what? By chain rule. So within the chain rule, we're going to employ implicit differentiation. Okay, because what are we trying to take its derivative? We're taking the derivative of x times y. So product rule, the derivative of x is 1 times y plus multiplied by x times the derivative of y, which is just y prime. So if you think about it, you know, say you still want to use, what's the derivative of y with respect to y? It's 1. But you multiply by y prime because of chain rule. So every time you have an expression of just y, what its derivative is just y prime, or dy by dx. Okay? And then the next thing we're going to do is distribute cosine over this sum. But let's rewrite this as y plus xy prime. See right there? I just had to show it here, that way you know that we did product rule on this expression of the derivative of xy. Okay, and then we distribute cosine of xy over this sum, and this is what we get. And I just put y in front, that way it's easier to recognize. And then xy times cosine of xy, rather xy prime times cosine of xy. And then what's the next step? You collect all the dy by dx, or the y prime expressions. And so that means I need to put this on the left side. And what do we get? So let's see. Remember, this is just a continuation. So far, that's what we did in the previous slide. And then we're down to solving for, we transposed, we combined all the y prime expressions on one side, so they're here, because I put this on the other side of the equation, and then this was left here on the right side, and then factor out y prime. So when you factor out y prime, what is left in the parentheses or in the brackets? It'll be 2y minus x times the cosine of xy, and it's equal to whatever is on the right hand side. And then finally, what's the last step? Divide both sides by 2y minus x times the cosine of xy, and we get this. So that means dy by dx is equal to this ratio. There we go, we found the derivative dy by dx of this function where y is implicitly defined in the equation. And this is how the graph of y squared equal to x squared plus sine xy, this is how it looks like.